Hi, everybody. Thanks for joining us today for our Philly Codefest workshop series. Today we have Satvik Triapti from the Drexel AI group. He's the vice president of the organization. He'll be talking about student experiences with AI. So you'll hear from Satvik about some of the co-op projects, and other examples of work that the group has worked on. The goal here is to give you some ideas of some potential projects for Codefest, and also fill you in on just AI in general and some of the different projects that they do with AI. Just to let you guys know, again, today's workshop is sponsored by Philly Codefest. If you have not already signed up for Philly Codefest, I will put the registration information in the chat below. Feel free to register. It's a free event. It is scheduled for April 4th to April 9th. April 4th to April 8th will be virtual, so you'll work together offline, and then on the 9th, we'll bring everybody together at 3675 Market for a closing ceremony. So with that, I'll turn things over to Satvik. If you have questions, feel free to put in the chat. I'll monitor the chat, and we'll have time at the end of the talk today for questions. And also, if you have specific questions about Codefest itself, I'll be here to answer those questions as well. So with that, take it away.
Thank you so much, David. So hello, everyone. My name is Satvik. I'm a freshman here at the College of Computing and College of Arts and Sciences. I'm a double major in computer science and psychology, and I'm double majoring in neuroscience and mathematics. I currently serve as a vice president at the Drexel Society of AI, and I am a research assistant at 4 different labs here at Drexel and Drexel College of Medicine. I am author of 2 book chapters in artificial intelligence and artificial intelligence-based medical imaging that I would talk later in my talk here. And I recently became a research fellow at Harvard Medical School in the Department of Biomedical Informatics. So I would talk a little bit about my research interest and how AI take part in all of these different areas of aspects, and how you could possibly think about different projects to do in all of these areas and even beyond, but these are what I work with. So first of all is the AI in medicine, which is we take questions which are medically relevant and important, and we try to solve them using the power harnessed by AI. So that means that like cancer detection, right? We could talk about like taking images scans, like taking like MRI scans of brain and running our AI model on it and thinking how we could extract these locations of tumor in each of these scans, which would help the doctor, not miss where the tumor is, and the machine could give it like on a very faster level and on a much more accurate level than the radiologist itself. So the AI in medicine basically comprises of developing models which solve the medically important questions. So personally, I am really well experienced with MRI scans, CT scans, PET scans, and X-ray scans. And one of the biggest advantage that I feel in this field is that you could give a top level of prognosis and diagnosis and detection at even the most rural part of the world. All you need is a technician who could run through the scan using the modality, whichever you're using on, and knows how to use AI, right? So with these 2 components, you could give like the same quality that we give here at Penn Medicine, like same quality of detection at Penn Medicine or at the most rural part of any world. Second, I would come on computational and quantitative neuroscience. It is slightly different from AI in medicine. And you could see like we use different modalities here, which is fNIRS, EEG, DTI, and fMRI scan. So all of these scans and modalities we use to see how brain functions, not just, so if you'll see the first kind of sequence, the MRIs and CT and PET and X-rays, they are more based on the structure of brain or in structure of the whole anatomy of whatever organ we are looking at. But fNIRS and EEG, all of these are more focused on how the brain activity works, right? And we could apply machine learning techniques to classify, say, imagine like in labs, what we do is like we ask a person to do a certain task, and then we could analyze that, okay, these parts of his brain get activated when we say to do this or when he's under stress. So in future situation, when certain of these brain parts get activated, or like these cortex get activated, we could predict that this guy is gonna go into a level of stress, and we could detect that beforehand, right? So which could be really helpful. So one of the example I would give here is something my lab is doing with Lockheed Martin, where we are like kind of generating these helmets for pilots, so we can measure the real-time pressure, stress level they have while they are in an in-flight situation. So that is the second example of the work I do. And the third is cognitive neuroscience and psychoanalysis. This is a really, really unique dimension to apply AI. So basically, if you'll know anything about AI, is that the whole branch of deep learning is derived from the fundamentals of neuroscience. As you know, the very basic model, the perceptron, is derived from the neuron of a human, right? So in the same way, we try to understand the whole neuroscience and make new models based on those neuroscience like fundamentals. Like for example, in like computer vision tasks, right? We are trying to go more towards like how our um, cortex works towards like the visual perception, right? How are there different neurons firing when we see a certain object, or we try to think about different objects, right? So it is a really important task to think about, because if you know, it takes like a lot of samples for a machine learning algorithm to understand the, if say, if you're running on a data set that has smiley faces and sad faces, it takes a lot of samples for that machine learning algorithm to learn that which one of the following is a smiley face and which of the following is a sad face. But for us as humans, it is rather really easy. Like even if you teach like a 3-year-old baby, even though he doesn't have seen a lot of people except for a few family members or random people on the street, he really understands like which face symbolizes happiness and which face symbolizes sadness, right? So it is really interesting to see how our brain is working, and it is so complex, and how we could derive the most out of it. And then we could apply all of these reasonings and insights, and we could think about creative thinking, problem solving, memory, and even neurodegenerative diseases, like how in the case of Alzheimer's, which parts of the brain decay that there's a loss of memory, right? So even learning about these, and then using techniques like EEG to know the correlation between the brain maps, and building logic towards the actions and thinking of individuals. And this logic serves as the fundamentals to build newer algorithms and building newer modalities that we would use in the coming future. So I would briefly introduce to my contributions in the research field. So currently I'm working with Dr. Hassan Ayas at the Neuroeconomics Lab. I've been there since September 21, since I came to Drexel. So we research on human subjects using near-infrared optical brain imaging, which is FNIR, and EEG scans for stress monitoring, analysis, and visualization of brain's cognitive response. I work on the data collection and conducting studies and building pipelines for real-time signal pre-processing and classification using federated learning. So a really unique term which comes up here is federated learning, and you could really use it for your projects if you're thinking to do. So federated learning is kind of a model for which you really do not compromise the user's data collection. Rather, you could send your model to that user, and basically run your model on user's device instead of taking his data and running it on your device. This way, you are not obtaining any data from the user and keeping it private. We use it in the medical field because we can't really extract or ask for data of patients from most of the hospitals because it's kind of like a breach of their privacy. So we rather build our algorithm, send it to their softwares, and our model get trained, and we don't know what data we are using, but our model get trained, and we use it back, and we could send that model to a different location and try to run it and test how good it's working. So this way, it is a really, really convenient way to train and test your model, and instead of like collecting all the data yourself and then running. Secondly, this is a second lab I work with Dr. Jessica Osborne at the Department of Neurobiology and Anatomy. I've been here before like joining Drexel. I was here since June 21. We integrate machine learning and data science techniques with biophysical realistic computational models for Drosophila neurons and develop formal descriptive mathematical models to directly derive and verify sensory motor integration algorithms to compute it in the neuronal path that transforms visual information into motor programs. So this could be a complex statement to think about, but what it's basically saying is that we target a particular neuron and see how it is. So Drosophila is a type of a bee, and we use their neuron. We have, so Google has provided us with a whole data set with the neurons, and we use a particular neuron and see how it is, and we make a mathematical model for it and see when it detects an object flying towards it or approaching it, how the neuron fires back to the brain and what activity does it does, right? And using this, we could compute what could be the possible way to integrate machine learning models here, or what ways can we optimize this whole propagations of chemical reaction between the neurons. So in this way, we work on the optimization and estimation of digital spike initiation zones located in the motor neurons. And third, I have been serving as the vice president here at Drexel Society of AI. And I'm recently leading a research project there on deep learning based radiogenomics model for lung cancer and reoccurrence prediction in non-smokers. And this whole project is mentored by a faculty at College of Computing. His name is Dr. Edward Kim. He runs the sparse coding lab that also I'm a part of. And it is in collaboration with Dr. Farouk Deiko, who is from UPenn Med Radiology Center. And I work on building the segmentation and prediction model and also helping the data pre-processing. So explaining a bit about this whole project is that we have CT scans of patients, and we basically run we pre-process the CT scans, and we try to segment where the cancer is in each of these CT scans, and we extract that information. Along with the CT scans, we also have their genomics and their clinical data. And combining all of these three data that we have extracted, we're trying to build a neural network, which basically helps us tell if there is a risk of reoccurrence, and we predict that, especially in non-smokers, because it is really, for clinicians, it's really hard to predict whether it's gonna reoccur or not, or even it's gonna bud or not, even though you never smoked in your life. But there are a lot of non-smokers who end up getting lung cancer. So this particular project is really essential and would play a vital role in the clinical setting when it's get applied. And this is, I recently received a research grant from the Drexel Undergraduate Research Fund and the Benoni Honors College for my project on a Turing test inspired method for analysis of biases prevalent in artificial intelligence-based radiology devices and models, which is also mentored by Dr. Kim and Dr. Deiko. So this is also really important subject to touch upon when you're working with AI. It is really, really essential to think about the biases which are prevalent. It is really important to think about what are the fairness concerns and what are the biases concerns when you're working with these modalities. A really good example of this would be, if you have heard about the controversies when the iPhone 10 was first launched, iPhone trained its neural network mostly on people of same race. So the iPhone, when used among the users, there was a significant better facial recognition in people with lighter skin tone than people with darker skin tone, which raised a huge concern about the biases prevalent in these technologies. And later, when the Apple resolved these issues by again using a federated learning model where it trained its neural network on various skin color and face types, and then as you can see now, the whole facial recognition is really fast and also really accurate. I will also touch upon a very interesting and fascinating example that I really like to share every time I'm speaking, which was back in the day when the computer vision came into play. Russian army, though it's in the very news right now, but it is an example here that a Russian army used the neural network to try to classify between an army vehicle and a normal car vehicle or a vehicle used by a civilian. So what they did is that they said, okay, we're gonna take pictures. So in the day, they take pictures of tanks and other military vehicles, and in the evening, they took pictures of cars, bikes, and a lot of buses and a lot of other civilian vehicles. And then they ran their model and they got an accuracy of 98% on their training data. And like they were like really happy that, yay, we achieved this huge amount, goal. And then when they started testing their algorithm on a validation or test data, their accuracy was staggeringly low. And a lot of people then criticize the algorithm that it doesn't work, it's flawed and everything. And then a few years later, a scientist came up that it wasn't the algorithm which was wrong. It was that the algorithm was picking up on a wrong feature. So it is really important to think about what features the algorithm picking up on. So what happened is that the algorithm saw if the pixels have a lighter color because they were taken in daylight, then it's a military vehicle. And if the pixels are darker in color, it's a civilian vehicle because the civilian vehicles were taken in mostly in the nighttime or the after sunset in the evening time, so the pixel color were kind of darker. So that's what the algorithm picked up on, and it classified it this way: that if the pixels are light, it's a military vehicle; if the pixels are dark, it's a civilian vehicle. And obviously, when you're gonna run this in a real life scenario, it's not gonna work. So this was an example that I really like to share, that even though you're running a model, it is really important to see if it is actually making the right classification. Moving on, I served as the abstract reviewer at the 60th annual meeting of the American Society for Neuroradiology at their symposium, which is going to be held in New York in July. And I've been serving as an honorary peer reviewer at the IGI Global Publication for my expertise in AI and biomedical informatics. I've been working there for past 2 years, and I've reviewed multiple international book chapters in AI medicine, advanced genetic algorithms, and graph kernel developments. And recently, I've been mentoring at deeplearning.ai. For those who do not know deeplearning.ai, it's a basically company run by Dr. Andrew Eng, who's really famous in machine learning. And deeplearning.ai provides multiple courses in various fields of AI. I work with the AI for medicine specialization taught by Dr. Pranav Rajpurkar, who is at the Harvard Medical School. And I help learners debug their assignment codes, answer their conceptual questions about deep learning architectures and radiological modalities in general. And this specialization in particular, like if they're struggling with any certain part or they have any technical problems, they reach out to me. And even before coming to college, over the past summers, I worked at a company called NeoSoma. If you are interested in any sort of clinical based co-ops, you could definitely look up this company and try applying there. I worked there for 6 months and built clinicians first and deep learning neurodiagnostic solution where it classified not just where the tumor is, but also what is the size of tumor, what is the characteristics of tumor, and how it's gonna prognose. And additionally, I was also a part of the FDA team for the company, so I sat in the meetings and talked about the ethics and regulation of our model. So if you're considering anything in this domain, I would really um, suggest that you could consider applying to this company. It was a really nice experience working for me. And during my senior year of high school, this was the first um, internship that I was ever a part of, especially in research, which was I worked with Dr. Afia Frieder at the Georgetown University for 8 years. I was assisting his lab with development of multiple graph kernel fusion for risk prediction of drug prescription given to patients. So basically, the question was that the prescription that the doctor is giving you, is it going to kill you or not? So we used the national health record of the Taiwan, and it was a data set containing 1 million patients and 1 million patients entitled of more than, I guess, 10 million features that we were extracting on. And I was assigned with the mathematical algorithm tuning out the graph kernel and working on the fusion pipeline. So it is really essential to understand the mathematics behind these algorithms. I've heard people in the field, especially in the industrial field, who say that it is not really important to understand the mathematics behind these algorithms. But trust me, when you get stuck and when you're thinking outside the box, it's the mathematics who gets the way out. Because when you know what actually the algorithm is doing, you know what to do and how to change the way it's working, right? Because at the end, all of these algorithms are statistical models, and it's nothing but a huge line of mathematical expression. So if you know how to decode that mathematical expression, and if you know what's going wrong here, you could fix the pipeline, right? And you could make a fusion model combining two of these mathematical equations to build newer models that we usually do in research. And I have individually worked on early prediction of Alzheimer's disease and detection of breast cancer lesions in young adults. So you could always look for these data sets online. There is this website called Cancer Imaging Archive, which you could look up to, which is very useful to find data sets in this domain. And you could always individually take some machine learning algorithms and try running on these data set and practice your skills. And if you get really good results, then obviously you could publish it in a journal or in a form of correspondence in any of the other magazines. So I have published three publications. I've published 2 book chapters, which are Artificial Intelligence, a Brief Review. So if you're a beginner with artificial intelligence, I would recommend giving it a read. And if you're more fascinated towards AI-based medical imaging and you want to know what are the different factors that we consider in regards to fairness and ethics, you could read my second book chapter, which was recently published, and it considers on the various aspects of where things go wrong. So it's a really nice read, and I wrote it with one of my colleagues in Germany. He is at the Technical University of Munich. His name is Thomas. So yeah, that's a really good read too if you want to go into that domain. And there is my third publication, which is on the early diagnostic prediction of COVID-19, which I published during the time of COVID-19 using a gradient boosting machine learning model. You could obviously take this look. It was a data set which was, I believe, released by the Israeli Ministry of Health, and I used that data set. I translated the data set into English, it was originally in their native language, and I ran my machine learning algorithm and got really good results. So if you want to see and read about that paper, you can obviously go take a look. So if you're wondering how I got into all of this machine learning, I would say it was all because of this guy. His name is Professor Andrew Eng. He is, if you don't know him, he's a professor at Stanford, and he's one of the most prominent faces when it comes to machine learning. I had the honor of working with him over the summers of 2020. I worked with him at the Center for AI in Medical Imaging, the AMI Center, and it was a fantastic opportunity for me. He is an incredible guy, and the way he teaches, there's no way you do not understand machine learning, because he not only explains how the model is working, but he really briefly explains the mathematics behind it. And that makes his course really, intuitive and really lifelike. So, and you could find all of his courses online on YouTube, and they are for free. And if you want to get a certificate for that course, you could obviously go to Coursera and get a certificate by giving some exams and going through the problem sets. And the second person I would give credit to is Dr. Kevin Brenberg, who is from Cornell. And he is a huge name when it comes to supervised and unsupervised learning. He runs this course on CS4780. It's Introduction to Machine Learning. And I highly, highly recommend taking this course, even though if you know about machine learning, trust me, take this course and you would be like, yes, I need to learn more about this stuff, because he is a phenomenal teacher, and just taking his course would give you so many ideas to work on various kind of projects, because as he goes deeper into different models, he talks about various ways to apply it in various fields. So, and it's just a delight watching him teach, and he's one of my favorite professors. So I highly recommend that. And then here's an example of the work I do. So here on the left, you can see an expert radiologist basically showing where the tumor is. And on the right side, you could see a machine learning algorithm, which is called a UNet, which is a UNet is kind of an algorithm which is made only for medical imaging and biomedical imaging. And you can see how accurate both of these algorithms, or both of like the segmentation made by the algorithm is. And when I showed this to an expert, he told me that the algorithm picked up on much better instances than the expert himself. So this is kind of an example to show how sometimes AI models can outperform the clinician. But sometimes people say that, does that mean we do not need a radiologist anymore? But no, that's not the case. It's just that having a radiologist in this loop makes it much more, reliable, that yes, the algorithm is doing the right thing for every single patient, because you cannot trust the algorithm on every single the training test data that we feed into it. It's not 100% sure that's going to give you the same accuracy for each single test that we are running it through. So this was one of the examples. And this is the specialization that I currently mentor. It's called AI for Medicine. Taking this specialization would give you so many ideas to work on various projects in the domain of AI and medicine. It contains 3 courses from detection, diagnosis, and prognosis. And you will work on different kind of data sets in the whole courses and work on building machine learning models and give you a first-hand experience with all of this field. So if you're interested in working in this domain, I would say that go ahead, take this course, and it's available on Coursera. And if you feel like not, paying, there's always an option for getting a financial aid on this course. And if you still don't want to go through all that process, you can audit this course and just go through the different modalities we explain and different techniques that we explain. So I highly recommend this course to you. So that was all from my side. And this is something I want to talk about, which is the Drexel AI Symposium we are hosting by the Drexel Society of AI. And it's again talking about all of the translations that AI has made in bioinformatics, medicine, and imaging. It would be held in person on 28th of May and online on 29th of May. You could scan this QR code or take a screenshot right now, and we could basically talk to you more about it. We are open for receiving posters, and we are open to receive abstracts right now. You could submit full paper if you want, and yeah, we would be opening registrations soon. So keep an eye. If you have any more concerns, we have our email ID right there. So take a screenshot and let us know if you're interested, and we'll keep you in the loop. And if you want to submit anything, go ahead, because the deadline is approaching soon. And if you're interested in this field, this is the first ever event to be held in the Philadelphia area targeting on this topic. So it would be a really nice experience because we are having speakers from UPenn, CHOP, Drexel Medicine, and a lot of speakers from Drexel itself. So it would be a really nice experience for all the learners, either if you're a beginner or you're an advanced person working in this field. So thank you. You can find me on these platforms. There's my contact information for my email ID, for my LinkedIn, Twitter, and if you want to join me on Slack. And now I'll be opening up for any questions do you have, and if you want to start any discussions.
So there is a question. Thank you. This presentation was fascinating. The work you're doing is really amazing, especially for a freshman student. So one question came in: where can I take Professor Weinberger's CS 4780 course? Is it free?
Yes. So Dr. Kevin Brenberg's course is free. It's on YouTube, and he recorded all of his lectures and was like, "No, I'm gonna put it on YouTube." And he is the only faculty who's, at least in the CS department in Cornell, whose course is present online on YouTube, and he hosted it on his own channel. So definitely take a look on that one.
Great. I actually have a question for you. Concerning Codefest, so these projects, the projects you're talking about are really, like I said, they're really fascinating. What is something smaller scale, something that can be done in like a week? Because Codefest is going to be basically a week's worth of a project that you have to complete in a week. What would be something that you would suggest that could be manageable in that time frame? What sort of project would it? I mean, medical there might be too much data out there for a medical project, but what are your thoughts on like a week-long project?
To be honest, the medical project doesn't take that much of time, because if you'll see, the data sets are available online, and a lot of data sets, Google hosts them on the Google Cloud, right? And if you're using Google Collab, you could literally just download all of this data into your Google Collab. And then you could use, like, there are various pre-trained models available. You just have to tune the hyperparameters and you're good to go.
Okay.
Yeah, so it's not that hard. It's just, if you read a few research papers, you will know that, okay, for this particular problem, is this particular case, people are using this particular algorithm. For example, for detection, people are using convoluted neural network, right? So you could just know, okay, these guys are using a CNN, we could try using that and try using it on a new data set and see where you go from there.
Okay. Well, that's great.
Yeah, and similar projects that I would say could be in autonomous driving, where you could download data sets. It would be it would be a much more bulkier data sets, because it would be videos, right, of the driving scenarios, but you could do a similar process in there. And you can always work on something like understanding the brain and working on the mathematics of it, it's not that hard. And it's really fascinating when you start working on it.
Okay.
Mhm.
Well, that sounds amazing. And I look forward to some of the projects we're going to see at Codefest.
Sure.
Any other questions out there? Anybody else have any big questions, either about AI projects, AI in general, or Codefest in general? If not, Savik, I want to thank you. I want to thank the Drexel AI group as well.
Mhm.
You guys have been integral in us getting this Codefest off the ground this year. This is now your second workshop, and we have another one scheduled for, I believe, March 31st, which will be a
Mhm.
hands-on workshop where actually get everybody coding.
Yeah.
Again, if you have any questions, feel free to reach out, either to me, and I can get your message to whoever needs to be at Codefest,
Sure.
or if you have a Drexel AI group, Drexel AI group has a great website that you can go on DragonLink. You can register for the organization there on DragonLink. Be on the lookout for more information about their conference coming up this summer. And
Mhm.
I want to thank everybody for attending. And Savik, I want to thank you and the Drexel AI group once again. Thanks, everyone.
Thank you so much.
I,
Thank you for hosting this.
no problem.